Hey guys, over the past few months I've been working on the MIT Mystery Hunts from 2022. The MIT Mystery Hunt is a yearly event that occurs every January where a bunch of teams come together to solve puzzles. This year's hunt was themed around books, so I've been solving a bunch of book-related puzzles. If I can show you the rounds quickly, the first round is called the Investigation, and it was like the intro rounds. The next one is called the Ministry, which is a bit meatier, and I did manage to solve it. And after that, we've unlocked something called Penn Station, which is where the rest of the hunt occurs, and all the puzzles are a lot harder. Right now, I have the New Orleans and Lake Erie rounds open. I'll show you those. New Orleans is themed around noir stories with these set of puzzles, and most of the puzzles I've solved so far in this Penn Station have been from this round. But I've also unlocked Lake Erie, and there are quite a few puzzles here as well. This is all horror themes, and so now I'm just going back and forth between these rounds, trying to solve as much as I can. So in this video, I will show you some of my progress in a particular puzzle, and hopefully make some more progress. That puzzle is the color outer space, which you can see right here. This puzzle actually has a story. It's about a certain professor who is looking at these long division problems left by aliens, and he's trying to decode them. But something happens to him. He succumbs to incurable madness, so now we have to finish his work. You can see he's done some work on this first long division problem, but these second and third ones are empty. So if you've never seen word arithmetic before, this is what this genre is. How a word arithmetic puzzle works is you have a long division problem, usually it's a long division, but instead of numbers you have words. And it turns out each letter is representing a certain digit from 0 to 9, and you need to figure out logically which letters correspond to which digits. If you look here, for example, the letter I will correspond to some digit, and according to the professor's work, we already know that the R digit represents 1, for example. You can see down here we have the keys, and that's already unusual because usually there's only one key in a word arithmetic puzzle. Each letter corresponds to a single digit. But as you can see here, we actually have two different sets, red and blue, and as it turns out, the set of digits in this puzzle are represented twice, once with the red colors, once with the blue colors. So for example, you can see that the red R represents the digit 1, but the blue P also represents 1. It actually gets even weirder than that though, because you might have noticed that the blue O represents the digit B. And that's a little bit strange, because B is not a digit. You have to realize that in the phrase frantic ghoul and weird phantom, each phrase has 12 letters, which means that the implication is that this alien number system has 12 digits instead of the normal 10, meaning that it's in base 12 instead of base 10. So that adds an extra layer of complication. So to follow along with this video, you probably should have some familiarity with how different bases work. Hopefully you do, or else this might be kind of tricky. You know, you can always leave a comment and I'll try to answer if something's confusing here. But that's the gist. There's this puzzle, there's also a second puzzle and a third puzzle which have no work done on them, but the idea is the same, and down here we have some stuff for extraction. So let me show you now what my sheet looks like. Okay, so here's my sheets. Usually I only do one tab per puzzle, but here I actually have 4 different tabs because there's a lot going on here. So on this main tab, I have the answers to the first 2 puzzles because I've already solved those. And so for the final extraction, I'll do it on this tab. Then I have the Work 1 tab, where I have the original puzzle up here. The key is on this left side, going vertically actually, and the answer with the correct digits replaced are down here. As you can see, it's in base 12, with the A's and B's representing 2 extra digits. But you can check this, and this is all valid according to base 12, unless I mess something up. Work 2 is the same thing, but with the second puzzle, which I actually did really quickly. I solved this in less time than it took me to set up spreadsheets. So this was very smooth sailing. And this is work 3, which You might notice it looks a little bit different. It's because we haven't solved it yet. I have some explaining to do because I've done a lot of setup to make this as easy as possible for me during the solving process. So I have all this extra space on the right here to take notes as I solve the puzzle. You can see I've already taken some notes here, which I'll explain in a second. But also I have a lot of formulas and conditional formatting in the sheets. So one thing I've done is I put the key here, and anything that isn't correct yet, I've colored in yellow. And so, for example, if you just look at this first one, I haven't figured out what pink B is representing yet. So I have a B here just to show that I haven't finished it yet. But if I figure out that B is 4, I'll put a 4 here, and then it goes white because I have formatting here to check whether a digit or an A or B is in the spot. And you might be wondering how the A and the B work, because wouldn't that conflict with the B that's already here? But I use lowercase letters, so it can distinguish between, or it's supposed to distinguish. I don't know why it's not working all of a sudden. Let me check the formula. Okay, with the weird exception of this example, it should generally work. It would be here to go whites. So hopefully this does not represent lowercase b, or else my formula won't work. But we'll see about that. You may also notice that these are not like the same set of letters that you saw in the original puzzle. If you have a good memory, at least, you'll see that this is ghastly demon and eldritch moan. And over here we have Buvagpuxies and Actahilmenarts. So the thing here is, first of all, I sorted these letters alphabetically for ease of solving. And second of all, I wanted to remove any repeated letters. So if you look at ghastly demon and eldritch moan, they repeat the E, for example. So the pink E and the green E represent different numbers. That's kind of hard to keep track of. And also, the formulas are easier if there are no repeats. So that's why I've changed the letters up. And I changed these long division problems accordingly. And this one down here is where the solving occurs. When I make a substitution like y equals 5, all of the y's down here turn to 5s, and they turn into a black color, which makes it easier to distinguish. So that's all the formatting I've done on the sheets. Now finally, let me explain what work I've done on this particular puzzle. It's very easy to figure out that q is 0 because being I minus q is I. So if you think about it, if you do any sort of carrying and subtraction, you'll never get the same digit back. So the only way that this is possible is if q is 0. There can't be any carrying from the leftmost digits over. And then once I figured that out, I noticed that s was interesting, because s times f was giving you something ending in 0. S times p gives you something ending in 0. S times j gives you something ending in s. S times k gives you something ending in s. S times y gives you something ending in s. So we have two different numbers that you can multiply with s to get something ending in 0, and three different numbers you can multiply with s to get something ending in s. And that seems pretty constrained, and it is. So in this s analysis area, I put all the possibilities for s, f, p, j, k, and y based on these restrictions. So I could go into more detail, but hopefully it's clear. So for example, for s times f to end in a 0, that means that s and f have to multiply to be a multiple of 12. So that's where this comes from. And for s times, like j for example, to end in s, that means that s times j minus 1 has to be a multiple of 12. So that's where all these come from. Okay, so that's all my progress, and now I will try making a new deduction. So I'm just going to zoom to here, observe this for a bit, take some notes over here, and then maybe once I figure out a new digit, I will let you guys know, and I'll show you guys all my progress from there. Okay, so at this point I've made some progress. I haven't figured out a digit, but I have figured out something that's probably helpful enough, so that's worth taking note now. So I'll tell you everything I figured out. First of all, a plus 1 is equal to t. That's pretty obvious because we have t minus 0 equals a, but obviously t and a aren't equal because they're two different digits of the same color, which means that the only way this is possible is that if t was borrowed from at some point, turning it to t minus 1, and then we subtracted 0 to end up with a. That implies t minus 1 equals a, so a plus 1 equals t. That's how I wrote it here. Then I was kind of stuck at what to look at, so I tried looking at pairs of subtractions that repeats. So for example, n minus f repeats here, and here, and here. N minus f is h in this situation, but it's c in these two situations. So I said that n minus f is related to c and h with this expression here. I also found that e minus x is related to 0 and to h. So put that here. And here c is 0 to be equal to h. And I also put, well, that's all I put actually for that. And then I thought that these first subtractions kind of caught my eye because we had a bunch of stuff subtracting to 0. So there's two ways that's possible. Either there is no borrowing in this last column, which means that n and x are equal, for example, in this case, or n was borrowed from, which means that we're actually doing n minus 1 minus x equals 0, in which case x plus 1 equals n. So they're either equal or they're one-off, basically. So, for example, from this example, we can get that k plus 0 equals t or k plus 1 equals t. So that's what I've wrote up here with this kind of condensed notation. Also, j plus 0 or 1 equals a because of the subtraction, and g plus 0 or 1 is l because of the subtraction. This leaves n minus x and e minus x, which both give you 0. And that's pretty interesting because that means that x equals one of them, and x is one off from the other one. So x and x plus 1 are e and n in some order. And that was a nice observation because that means that e minus x is either 0 or 1. But up here I said that e minus x is related to 0 and h. So h has to be 0 or 1 because those are the only possibilities for e minus x. And I'm guessing that h is 0 because we already know 0 is a possibility up here. But that is not necessarily true. So if we had e equaling x plus 1, or in all caps equaling x plus 1 up here, like this, we're subtracting x. If a borrow occurred, then this e would be reduced just to becoming x, and x minus x is 0. So even if e is x plus 1, this is still possible to get 0. So I think we can't make any deductions yet whether h is 0 or 1 unless I find something else. So I'll try finding something else. Okay, so before I go and make a new deduction, I realized that I made a mistake here. I should be more careful in saying what h could be based on this. So I know that e is either x or x plus 1, but this is just saying that e minus x is related to 0 in h. It's actually saying that I have e and x on top of each other. It could be 0 or h down here. But I don't know what borrowing is occurring yet, so I wasn't being very careful when assigning values to h. To be more careful, I consider two possibilities. Either e is equal to x, or e is equal to x plus 1. So either have an x on top of an x, or an x plus 1 on top of an x. And so, for each of these, there's two subcases. Let's do the first example. If we have x on top of an x, and x is not borrowed from, then x minus x gives 0. So 0 is one possibility for h. If instead it is borrowed from, then by the time we get to this column, we'll be doing x minus 1 minus x, which requires a borrow. So we'll end up adding 12 to this, and that turns into a plus 11. And x plus 11 minus x turns into b. So b is another option for this, b representing the value 11. On the other hand, if we do x plus 1 minus x, we could get 1 as a remainder, but if there's a borrowing, then it'll be x minus x, which leaves 0. So if you go through more carefully, you can see there are actually 3 options that are available for h. And yeah, those are all possible right now, so I'll need to do some more work to figure something else out. Okay, I found a digit. It has nothing to do with all this work that I did up here. It's something completely different. I just suddenly noticed that this was here. I have an OYO thing going on. That's pretty unusual. So, if O isn't borrowed from and it just stays O, then this is impossible, because this is only going to work if Y is 0, but the pink 0 has already been assigned to Q, so that's not going to work. So it must be the case that O is borrowed from before we get to this position, which leaves us in this scenario. Well, that's not necessarily true, actually. Okay, so there's another possibility that I haven't considered yet, which is that O itself equals 0. So hopefully that does not affect the logic too much. It's another case to consider. In that case, we have something like this, and then when 0 is borrowed from, what ends up happening is that we borrow from a neighbor somewhere on the left, and that eventually comes back around, and we end up with 12 minus y equaling 0. But that's actually not going to work, because that would imply that it's like 12 minus 12. That doesn't make any sense. Yeah, that's not going to work. So actually, I didn't consider it, but the case where O equals 0 is not correct either, because there's no value for y in that situation. So hopefully it's clear why O can't be 0. In that case, when the wiring occurs, we'll just take from the O and it becomes O minus 1, O minus 1 minus y. So what could that be? For that to be O, first of all, y has to be bigger, or else there won't be any borrowing, and there's no way for a smaller number to become a bigger number. So y has to be bigger, which means that we have to borrow and add 12 to this, which means a plus 11. So if O plus 11 minus y is O, that means y has to be 11, or in other words, lowercase b. So we actually get that green y is lowercase b. Where is it? No, not green y, pink y. Pink y is lowercase b. Although, I think that might be the only y. No, there's actually y up here. Oh, that's actually nice. Yes, we end up with a y up here. Okay, that's interesting. Okay, that's actually really good. Okay. So with that y being assigned to b, that's really lovely. Because y is one of these digits, and according to this, the jky values are all here, but there's only one situation where y could ever equal b, and it's this situation right here, which means that this must be the correct situation. All these other ones are wrong. It implies that s equals 6. F and p come from this set, and jk and y come from this set. So we already figured out y, but that means that j and k are 1, 5, 7, and 9 in some order. Okay, so that's really nice. Because I figured out what s is, it gives me all of these, which are pretty nice. Whoa, what's going on here? I'm getting an O6N situation. I can type things O6N situation and N6O situation. So what explains this? Well, they can't both be non-borrowing. That's mathematically impossible. So it must be the case that one of these is a borrow. Let's just say that lost generality that n is a borrow, so we have to add 12 to this, then subtract 6. So we end up with O equals n plus 6. Okay, so this is actually fully consistent, because it also implies O equals n plus 6. Okay. So one of them plus 6 gives you the other one, but you don't know which one yet. That's what it means. So, how I can write that is, if I want to write that over here, I can say that L plus or minus 6 gives you M. One of them plus 6 gives you the other one. We also have this C over top of the 6 giving you an A, which I guess is sort of like the same deal. If it's just no borrowing, then C minus 6 will just give you A, so A plus 6 equals C. If there is borrowing, then C plus 12 minus 6 is A, so C plus 6 equals A. So we can also write that down. A plus minus 6 plus minus 6 is giving you C. Right, that's this thing right here. It's hard to say anything about this, these subtractions. Well, no, this is actually something the same as this. It doesn't help at all. This one is less informative because we don't know if L is being borrowed from or not in this situation. Okay, well, let's see if I can figure anything else out. Okay, so for a smaller deduction I just made, first of all, because I knew S was 6, that gave me some restrictions on these possible digits. I put those restrictions right here, keeping in mind that these are pink digits, and so they can't equal any of the pink results we already had taken. So once you account for that, these are the possibilities for F, P, J, and K. And then I noticed that because we had B, because we had this multiplication, I kind of wrote that over here. So this PJK number times B gives you something ending with a 6. And so 6 times B I use just like an online base calculator. Apparently equals 5, 6. So you put the 6 here, carry the 5. That means that 11 times b plus 5 gives you something, because the next digit here is an f, it should give you something that's congruent to f modulo 12. That's what I have here, and if you look at the possibilities for f according to this result up here, that gives you some possibilities for 11 times b, which in turn gives you some possibilities for b. So that's what I wrote over here. So this is just the values of b that give you valid values for f based on the restrictions that we've already figured out. So I think I figured out another digits. I did it by looking at this multiplication, this first one right here, where this pjk number gets multiplied by ft equal to this number. And I wrote out that multiplication over here on the right. So because we have restrictions on f and b, and we have f and b as digits here, I thought that maybe we could do some deductions for the possibilities for f and b. We need 6 times f to end in a 0, and that means that f is either 2, 4, 8, or a, and then b needs to be a value where f times b plus whatever the carry is gives you something ending in a 6, and b can only be 4 options. So I simply just went through all the possibilities and found that only 2 possibilities actually worked. Either f is 4 and b is 1, or f is 4 and b is 7. So first of all, that tells us that f is equal to 4, like that. And also b is equal to 1 or 7. And because f is equal to 4, I can delete it from here, and delete 4 as an option for p. Alright, so I did the same analysis with the next multiplication, the one ending in 0, 0, and I copied it over here. And I figured out that with b only being 1 or 7, and b only being 2, 8, or a, the only way this could work with these last 2 digits being 0, 0 is if p is equal to 8. b could be 1 or 7, they both actually work, but when p is 2 or a, there are no solutions that work. That tells us that p equals 8. Delete this. Okay, so first of all, I made kind of a big error. When listing the options for j and k, I forgot to mention that 3 was a possibility, even though it totally is. Back here when I made this table, when I listed all the possibilities for all the digits, I somehow missed the 3. I don't know how I did that, but I did. And this is where it matters, because it breaks otherwise. And I'm pretty sure I didn't use the set of digits for any other deduction, so I think everything else I have is still correct. But that is an unfortunate mistake, and I don't even know how I made it. Hopefully with the inclusion of that 3, this becomes possible. 6 times 3 gives you 1, 0. Yeah, this makes it possible now. Okay. So here's a deduction that I made that didn't work at first. I was looking at this next multiplication, this one ending in 6, 4, 6. And I noticed that it was the results of the product of j and b giving you this 4 here. But if you think about it, j and b are both going to be odd numbers. So we're multiplying 2 odd numbers, and we're adding some unknown carry to give us an even number because it ends in a 4. That means that this has to be something odd. But this carry will be the tens digit of 6 times j. So if you look at all the options for 6 times j, there are 2 of them that have an odd number in the tens place. So these are our 2 options. Before, I thought that 6 times 7 was the only option because I forgot the 3, but that doesn't actually work because you carry the 3. B has to be 1 now because J and B are both the same color, they're both pink. So if J is 7, that means that B has to be 1 is the only option. But 7 times 1 plus 3 is definitely not something ending in a 4, because 7 times 1 plus 3 is A. So yes, this is not going to make any sense. So this is wrong actually, leaving the only possibility to be 6 times 3, so hopefully this works. I didn't actually check this yet. This is not even right. I don't know why I put 1 0 here. It's 1 6. But 6 times 3 is 1 6, carry the 1. So we want 3 times something plus 1 to end of 4. So what's 3 times 7 plus 1? 3 times 7 is 19, or 19, I guess. So what that means is if you add 1, it'll be 1a, which is not ended in a 4. So b equals 7 doesn't work. B has to equal 1. So you get b is 1 and j is 3. This is 0 carry. So we know that 3 times u is something ending in a 6. And there aren't that many possibilities left for digits, actually. What's remaining? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, and B. But we've already used 1, 4, 3, 8, 0, 6, and B. So U can be any of these digits, 2, 5, 7, 9, and A. How many of them, when you multiply by 3, is something ending in a 6? Let's test it. 2, 5, 7, 9, A. 3, 5, 7, 9, A. So it looks like 2 and A are the only ones ending in a 6. That means that U is equal to 2 or A. Since I figured out J and B, I will remove those. So J I know is equal to 3, and B I figured out. Alright, so I tried out the two possibilities for U, 2 and A, into the same multiplication. I plugged it in up here, but actually I can also plug it in down here. This will be 2, and this will be A. Like that. So, if you look at this possibility, it doesn't work, because 3 times 2 is 0 carry gives you 6 with 0 carry, but 3 times 8 is 2, 0, but that would make x equal to 0, but we already figured out what the pink 0 is. It's q. So this is totally wrong, leaving us with this option. So we have 3 times a, which gives you 6 with 2 carry. 3 times 8 plus 2 is 22, so x must be 2. Let me make sure it's right. 3 times 8 is 20, yeah, so it'll be 2, 2. So that means that x is 2. And so it'll be 2 with 2 carry. So 3 times k plus 2 gives me something ending in k. And the options, I believe, are 5, 7, 9, and A. I believe that's right. 5, 7, 9, and A. Just try all of them. 3 times 5. It could be 2 times 5. 2 times 7. No, that would not work. 9. That would not work. 3 times A. That would not work. So the only one where if you multiply it by 3 and add 2, you get the back to itself is 3 times 5 plus 2. So that must be it. We get that k is equal to 5. So 7, 9, and A are the remaining digits here. I'll put that right here just for keeping track. We have almost all the pink digits now. Oh, I forgot to even let they use 2. Wait, something's up. No, I did. That's 2. What is U? U is A, sorry, yes. So actually only 7 and 9 remain. 7 and 9 remain. So G and Z are 7 and 9 in some order. That should be possible to solve. Yes, we just need to look at like literally any multiplication. So for example, we have this number times 8 is giving us this number. So 6 times 8 is 40. 8 plus 1 times 8 times 1 plus 4 is 10. And 8 times a plus 1 will be 6, 9. So z is 9. Process elimination tells us that g is 7. So we've actually figured out the entire set of pink digits before figuring out a single green digit, which is kind of surprising to me, but that is how it ended up turning out. So let's see what I can do now that I have all the pink digits. Okay, so since I figured out all the pink digits, I looked back at these earlier notes and replaced all of the pink letters with their proper values, and that did give me a new deduction. We know that a is 3 or 4, and that t is 5 or 6, but a plus 1 equals t, so the only way that's going to work is if a is 4 and t is 5. And since we know that a plus or minus 6 equals c, we can't subtract 6, we have to add 6. So 4 plus 6 is a, meaning that c is a. C is a. We have a lot of information over here with this 06 and 470 stuff. So let's look at that. By the time we evaluate this first column, we won't know if we borrowed from the 4 or not. So in one situation, we haven't borrowed from the 4, in which case we're doing 4 minus 7. This is if no borrow occurs. Then we'll have to borrow from a digit from the left. E could be 0, but anything from the left we're borrowing from. And that would add 12 to this value, and then we're subtracting 7, which results in a 9. In the other case, if we do a borrow, then by the time we get to this column, we'll actually be doing 3 minus 7. So when we add 12 and then subtract 7, we end up with 8s. But that's not possible because if O is 8, that means you're doing 8 minus 6 over here, and that would be 2 without borrowing, but this is the borrow situation, so that's a contradiction. So that means you have to have no borrow. O has to equal 9, which means that N is also equal to 3 because of the subtraction. So O equals 9, and N equals 3. And if you look at these notes for another second, you'll see that with N equaling 3, E has to equal 2 because of this. So E minus 2 is here. We're still having 2 minus 2 is H. So we could do something over here actually, because let's do that. So we have 249, and then 276. We already covered this. This is going to be 3, and then this 47 is going to borrow from the 2, and that will leave 9. And then since we're doing 1 minus 2, we're going to have to borrow from something to the left, turning this into 1 plus 12, subtracting 2, so this will give us a b, implying that h equals b. Okay, now I'm just looking for some really easy stuff. We should be almost done here. I see here that we're just doing a minus 6 equals 4 with no borrow. So that means I is just 2 plus 4, which is 6. Then over here, we're doing this takes a borrow, this borrows, this does not borrow, B minus 1 does not borrow either. So we're doing a minus 3 with no borrowing, which gives us a 7, so R is equal to 7. Then a minus 2 with no borrowing, so L is equal to 8. Then n minus 7, we are doing a borrow because this needs to turn to a 7. So we're eventually going to add 12 to this and subtract 7 to give us a 6, so m is equal to 1. And with process of elimination, the very last digit is the 0. So that's going to figure it out. And just to check, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. L is indeed 7 or 8, like I said earlier. This is not important. Okay, so it looks like I've solved everything, but I am going to use this base calculator and check every single step of this to make sure that the math is correct. Alright, so I reformatted everything here to look like the other two finished work tabs. So everything is cleaned up. All the digits are still here, but I replaced them with the correct substitutions, Ghastly Demon and Eldritch Moan, and I copied that information into this final worksheet where I have all three answers. And you can see I also have some stuff down here. That all comes from the bottom of the puzzle, which has these division problems and some question marks and some more story. So I think the goal here is just to translate these and figure out what the correct letters that go into these spots are. So I'm going to try doing that. So for PH, that's going to be 1, 2, and then NGLUI. The N and the L are red, so it's going to be 3 and 9. The G and U and I think are all dark red. Yeah, so that's going to be 0, 5, and A. So we have this division. Let's see what that becomes. 3095A divided by 12. 2765. 2765. So let's just save that for now. 2765. We'll convert that to letters in seconds. This next one we have M and A in green, 1 and 4. Then G in dark red, which is 0. Then L and F, which are in red, which is 9 and 0. Then W and N in blue, which are 9 and 5. And H is in pink, it's 9. So 5409 over 10899. Which is 5. So we get 5 as the result here. Now let's just try. I don't know what to do with this Cthulhu and FHTAGN stuff, so I'll save that for later. R is 7 for this next division problem. And then we have L, Y, E in pink, and H, 9B19 over 7, 1503. And finally we have this, WGAH, oh wait, it's the wrong color, W, and then GAH, divided by N, A, G, L, A408 over 272. 4. So we get 4 here. Now we got 4 here. Alright. So let's convert that into letters. So this is in a lighter color, and that becomes a W here. This is in a darker color, becomes an H. These are both green, and become IT. And then this red 5 turns into an E. And this red 1 turns into a T. This is dark, and it's a 0. This is white, and it's an N. This is an I, and this is dark, and it's C. White Cthulhu, Tunic. Do we need to, what do we do here with these black letters? I'm not sure. White Tunic? Is that a thing? just meant what tunic? Oh, it's correct. That's not really a thing, I don't think. I don't really understand what this Cthulhu fatigue and stuff is. But I've solved the puzzle, so I will not complain. Answer is white's tunic. Alright, that's it for this video, and I hope you enjoyed watching. Okay, I said I was going to end the video there, but actually, I have something else to say. Because I was wondering what was up with these, this FHTAGN and stuff. And this last part just seemed kind of weird to me, I didn't really understand it. So I read the solution, and it turns out there is a significance to those last parts. Apparently, this phrase is a very well-known expression among fans of Lovecraft's work. And actually, this is actually really cool. Everywhere there's an apostrophe, they replaced it with a division sign that kind of looks like an apostrophe, but it looks exactly like this, just with the division symbols, and that was what was actually used in this extraction. So that's really cool, and I understand now why they left this as extra, because there's no division symbol here, so it wouldn't work that way. So yeah, that's really cool. Yeah, so I thought that was worth mentioning, but yes, now I'm ending the video for real. See you later.